Monostable Multivibrator with 555 timer. The operation and output of the 555 timer monostable is exactly the same as that for the transistorized one we looked at previously in the Monostable Multivibrators tutorial. The difference this time is that the two transistors have been replaced by the 555 timer device. When a negative 0V pulse is applied to the trigger input, pin 2, of the monostable configured 555 timer oscillator, the internal comparator No1, detects this input and sets the state of the flip-flop, changing the output from a low state to a higher state. This action in turn turns OFF the discharge transistor connected to pin 7, thereby removing the short circuit across the external timing capacitor, C1. This action allows the timing capacitor to start to charge up through resistor, R1 until the voltage across the capacitor reaches the threshold, pin 6, voltage of 2,3 VCC set up by the internal voltage divider network. At this point the comparator's output goes high, and resets the flip-flop back to its original state, which in turn turns on the transistor and discharges the capacitor to ground through pin 7. This causes the output to change its state back to the original stable low value, awaiting another trigger pulse to start the timing process over again. Then, as before, the monostable multivibrator has only one stable state. The monostable 555 timer circuit triggers on a negative going pulse applied to pin 2, and this trigger pulse must be much shorter than the output pulse width, allowing time for the timing capacitor to charge and then discharge fully. Once triggered, the 555 monostable will remain in this high unstable output state until the time period set up by the R1x-C1 network has elapsed. The amount of time that the output voltage remains high, or at the logic level 1, is obtained by the time constant equation you see. A monostable 555 timer is required to produce a time delay within a circuit. If a 10 microfarad timing capacitor is used, calculate the value of the resistor required to produce a minimum output time delay of 500 milliseconds. If this time difference of 17 milliseconds, 500 to 517 milliseconds, is unacceptable, instead of one single timing resistor, two different value resistors could be connected together in series to adjust the pulse width to the exact desired value, or a different timing capacitor value chosen. We now know that the time delay or output pulse width of a monostable 555 timer is determined by the time constant of the connected RC network. If long time delays are required in the tens of seconds, it is not always advisable to use high-value timing capacitors, as they can be physically large, expensive, and have large value tolerances, E.G, plus or minus 20%. One alternative solution is to use a small value timing capacitor and a much larger value resistor up to about 20 megaohms to produce the required time delay. Also, by using one smaller value timing capacitor and different resistor values connected to it through a multi-position rotary switch, we can produce a monostable 555 timer oscillator circuit that can produce different pulse widths at each switch rotation. We can manually calculate the values of R and C for the individual components required, as we did in the previous example. However, the choice of components needed to obtain the desired time delay requires us to calculate with either kiloohms, megaohms, microfarads, or picofarads, and it is very easy to end up with a time delay that is out by a factor of 10 or even 100. We can make our life a little easier by using a type of chart called a nomograph. Nomograph will help us to find the monostable multivibrator's expected frequency output for different combinations or values of both the R and C. So by selecting suitable values of C and R in the ranges of 0.001 microfarads to 100 microfarads and 1 kiloohms to 10 megaohms respectively, we can read the expected output frequency directly from the nomograph graph, thereby eliminating any error in the calculations. In practice, the value of the timing resistor for a monostable 555 timer should not be less than 1 kiloohms or greater than 20 megaohms.